Okay. So today important algorithm we are seeing it is a banker's algorithm. So in the last class we have seen about deadlock avoidance, how to avoid a deadlock. So then we have something called as a safe state. So when do we say safe state and safe sequences? When the deadlock is not occurring, then we call it as a safe state. And safe sequence means I may have some process. Suppose let us take here in this P1, P2, P3, P4. In which order if I execute my process, then my there will be no deadlock and there will be a safe sequence. That is what is called as a safe sequence. That's what in this diagram we have just seen about when do we call it as unsafe, when do we call it as a safe. So when do we say safe? When all the process are executed, then we call it as a safe. When do we say unsafe? Some process are not executed. Uh, the resources waiting for each other, then we call it. Then we say it is a deadlock has occurred. These are the things which we can see in this. So now we move on to a bankers algorithm. So this is very important algorithm. So bankers, why they have developed, why the name bankers algorithm is this algorithm will be used or it will maximum sorry maximum will help for a banking sector. That's why the name given is a banking algorithm. So we'll see what it is. So the resource allocation graph algorithm. So what is this resource allocation graph? Now, suppose you think you are five people, five friends are there. So let me take Bhavisha, Chaitra, Mithali, Shruti, or some five people are there. So five people. How many resources you want? You want one may require CPU, one may ask for memory, one may ask for printer, one may ask for computer, one may ask for mobile. Something like that you may ask. So how which one should I give you? To whom what all resource I should give you? That's what we see here. The resource allocation graph algorithm is not applicable when there are multiple instances for each resource. So this can be used. Suppose how can is not applicable means if I have so multiple instances, then this algorithm cannot be used. The Bankel algorithm address this situation, but is less efficient. So this algorithm is uh, addressing the resource allocation graph, but it is not so efficient than the earlier algorithm. So now the name, why the name? The name was chosen because this algorithm could be used in the banking system. Why do the bank name of the banker's algorithm? Because I told you this algorithm can be used in a banking system to ensure that the bank never allocates its available cash such that it can no longer satisfy the needs of its all customers. So why this algorithm can be used in banking is, so in bank some cash will be there. Let us take some lakhs one day. If we consider for one day, maybe for 100, 1 lakh or 2 lakhs. So in that case, you may have your banking accounts in that bank. Then until unless you ask the money, they may not give you the cash, but it will be available in your transaction how much amount, how much balance thing. So that's what here we see how this algorithm works. When a process enters the system, it must declare the maximum number of instances of each resource type that it may need. So what it says, now you are five people, five of you are there. So five of you, Bhavisha can ask, I want five CPUs. Chaitra can ask, I want four printers. Mithili can ask, I may require some more five laptops. Something like that you may ask. But what banker algorithm says to you is before you start your execution, before you start the event, then only you say, I want this much, I want this much. That's what here it says. When a new process enters the system, it must declare the maximum number of instances of each resource type that is needed. Maximum means how many I want. I want five CPUs, I want five laptops, I want five printers. Like that maximum you can say how much I want to complete my work. Then type which one I want, whether I want CPU, whether I want memory, whether I want printer, whether I want laptops, type which type. That's what resource type. This number may not exceed the total number of resources in the system. Okay. So how much is available in the college? 4 printers, then you can only ask for 4 printers. Then you cannot ask for 5 or 10 printers because it is not available. That's what here it should not exceed. This number may not exceed the total number of resources in the system. When the user requests a set of resources, the system must determine whether the allocation of these resources will leave the system in the safe state. So what is this algorithm says to us is when a user requests a set of resources, the system must determine whether the allocation of these resources will leave the system in the safe state. Okay. Now Chaitra is asking for 2 printers, uh, 2 CPUs, and 2 memory allocation. Then I should say if I allocate all these things, whatever Chaitra has asked, if I allocate, deadlock is not occurring. That's what safe state. Safe state means what? Deadlock is not occurring. That's what it says here. If it will, the resource are allocated. Otherwise, the process must wait until some other process release enough resource. So now, or suppose if it is not sufficient, then you have to wait till Maithili relieves, gives back her work is completed and gives back her CPUs or laptops because she has completed her work. The remaining she can give back. That's what here others have to wait. That's what this says to us. Okay. So what are the data structure? What do we mean by data structure? Which type of data we can use and what are the limits we have?
Yes, ma'am.
Yes, ma'am. Yes, yes.
Ma'am, PPT is not visible, ma'am.
PPT is not visible. How come?
No, ma'am.
PPT is not visible. 1 second. Let me. You should have told me before only I would have checked it. Okay. Good. Because I'll not be knowing. I am seeing here. I am able to. Okay. Now able to see.
No, ma'am.
What happened? I'll just restart. I'll
Okay.
just restart this Google Meet. I think now you may see. Now you are able to see. Able to see?
Yes, ma'am.
Okay, thank you. Now here what we see is ranking algorithm. This is a very important algorithm. Why? Because not only for your exam point of view.
Ma'am, it got zoomed.
Uh-huh.
Like only half of the page it was visible, ma'am.
Only half?
Yes, ma'am.
I
Ah,
don't.
now it's okay, ma'am.
Uh-huh. What happened?
Now it's okay.
Now it's working. Okay. Okay. Why this banking algorithm is important is the banking algorithm not only for your exam point of view, but they may ask you in your placements or they may ask you in your interviews. That's why this algorithm is important. So what is this banking algorithm
Ma'am,
is
again
for?
it got changed.
Uh-huh. Yes.
Again, it got changed, ma'am, like half of the page.
Why it is happening like this? I'll restart again. I'll just see what is happening. I don't know. Oh, it closed. Now able to see? Able to see now? My voice is also.
Ma'am, that half part we can able to see.
Whether you're able to hear my voice?
Now it's okay. Now it's visible. If you zoom, it means half of the portion is not visible, ma'am.
Okay. I'll not zoom. But here, see, what it is saying is audio is not visible. I don't know what is happening today with this Google Meet. Okay. I'll just increase the size. Now you're able to see?
Yes, ma'am.
If I make it full screen, it is not, you're not able to see.
Yes, ma'am.
Okay. What I'll do is whatever is available. Okay. So what we were discussing is we were discussing about Banker's algorithm. So Banker's algorithm is very important, not only for your exam point of view, but that's what I told. It is also required for uh, for your interviews as well as placement as well as for your exams. You may expect a algorithm compulsorily. That's what it's okay if I take some time also. I want to explain it completely. Able to hear me?
Yes, ma'am.
Okay. The resource allocation graph. So what is this Banker's algorithm? Is the resource allocation graph. A resource means that's what. So you are four people and I want to allocate resources for all four. And how many I have with me. So I may have five laptops. I may have two printers. I may have four. What else I can say? Some textbooks. Five textbooks I have. So then you three people have asked me. Chaitra have asked me to give two textbooks, one laptop, one printer. Whether available with me? Yes, it is available. Then I can give so that she can complete her work. So in the same way, now Mithili wants her work to be completed. She may ask me 10 laptops, 10 books, and three printers, something like that. But right now, I don't have. And I don't have so much resources to give to Mithili. Then what I have to do? I have to wait till Chaitra completes her work and gives back her resources. After she gives back, uh, if it is available, then I'll give to Mithili. And in the same way, Bhavisha will also ask me some other resources. So, what resources Bhavisha may ask? She may ask one CPU, one printer, one book. Yes, it is available, then I'll give to Bhavisha. I'll make Mithili to wait until unless these two people, Bhavisha and Chaitra, gives back me all those things. So that's what here the banker algorithm says to us, or resource allocation graph. So the banker addressed this situation, but it is not so efficient as the others. The name was chosen, that's what I told, the name was given because this algorithm can be used for a banking system. Okay, so then before only you start your work. So Chaitra starts her work. Starting only she has to say me how many printers she want, how many CPU she want, how many books she want. Before only, what is her maximum number of things she requires so that she'll complete her work. That's what here when a process enters the system, it must declare the maximum number of instances. Instances means number, how many I want of each resources type. What, how many printers I have to give, how many resources I have to give, how many other things I want to give. That's what here type, resource type, CPU or printer or books. This number may not exceed the total number of resources in the system. Okay, whatever I have 5 CPUs, I have 3 printers, I have 10 books. If any others ask me 20 books, I don't have. I have only 10 books. I can give you only 10 books. That's what it should not exceed whatever I have. When a user requests a set of resources, the system must determine whether the allocation of these resources will leave the system in the safe state. So what do we mean say by safe state? Safe state means what? It should not the deadlock should not occur. That's what we have seen in the earlier slide. When do we say unsafe? When do we say safe? Safe means deadlock is not occurring. Unsafe means what? Deadlock is occurring. If it will, the resources are allocated. Otherwise the process must wait until some resource release enough resource. That's what I told. For Bhavisha to give so many, I have to wait till Chaitra completes her work, till Mithili completes her work. That's what here, because if they give, the resources will be more with me, then only I can give for Bhavisha whatever she has asked. That's what here all these are. Okay, so now data structure means what? What type of, now I told allocation. So now what I'll do, I have 3 resources. What I told, I have 5 CPUs, I have 2 printers, I have 10 books. Where, how, which data structure should I have? I should use integer, should I use array, should I use stack? That's what here data structure algorithm, which data structure it is using. Let n be the number of process in the system. So n means what? I have a count. So how many CPUs I have, how many printers I have, how many books I have, something like this we say. Number, how much number, and M be the number of resources. So how many process? I am 1. How many of you? 3. So 3 processors means Chaitra is 1 process, Bhavisha is 1 process, Mithili is 1 process. Like that, number of processes. And how many resources? How many printers? How many books? How many CPUs? Like that, how many are there? So that's what here M stands for resources. Available. So first we should see how many are available. What is maximum you people are asking? Can I allocate? How many you need for your work to complete? That's what here all these explains. Available means I say, I told I have 5 CPUs, I have 3 printers, I have 10 books. So how many is available with me now? Right, resources available. I have 5 CPUs. I have how many printers? 3 printers. How many books I have? 10 books. That's what is called as available. Vector of length m indicate number of available resources. How many resources I have? Suppose if you assume I am the operating system, I have all these with me. And you are the 3 processes. Chaitra is 1 process, Bhavisha is 1 process, Mithili is 1 process. Available, how many I have resources available? 5 CPUs, 3 printers, 10 books. These are called as available. If available j equal to k, there are k instance of resources type rj available. So what it say? Available is, so many are available. How many? 5, 3 and 10. So count all these, how many are available? 10 plus 3, 13, 13 plus 5, or 18. Total available resources, how many I have? 18. Out of 18, which are CPU? How many CPUs? How many books? How many printers? That's what if available. J means what? Resources. How available CPUs equal to K. How many available with me now? How many available CPUs? 5. So 5 is equal to 5. There are K instance of resources type RJ. Resource, what type? CPUs. That is what it says. Maximum, how many maximum? That is limit. How much is the limit? N cross M matrix defines the maximum demand of each process. If max of I comma j equal to k, then process pi may request at most k instance of resource type rj. So what it says? Maximum. So how many maximum uh, do I have so much space to store all these? That's what here maximum says. Allocation, I told you in beginning only. Chaitra wants one CPU, one printer, one book. Yes, it is available. I have all these three. I can give to Chaitra. So then the same way, Mithili asked me 10 CPUs. Right now I don't have. I don't have only 10 printers. Then what? I have to wait. If others gives, if I have resources 10, then only I can give to Bhavisha. That's what like that allocation. Need, how many you need? Before only, before you come to the CPU, you'll be saying for to complete your work how many you want. Chaitra may say that I want to complete my work, I want 3 CPUs, 2 printers, 5 books. Yes, if it is available with me, I will give to Chaitra. That's what here need. So need is what? N cross M matrix indicating remaining resources needed for each process. That's what each process. How much each process, if I consider Chaitra is one process, Bhavisha is one process, Mithili is one process, then how many I require? Need. How many you need? That's what here need says to us. If need I comma j equals to k, then pi may need k more instances of rj to complete its task. So then how do we give a need? Need of I comma j equals to maximum of I I comma j minus allocation. We'll see. This will be clear for you when we take an example. But before that, at least little bit you have to understand about the algorithm. Okay, so in banker algorithm, so there are two parts. One is safety algorithm, and another one is resource request algorithm. So in banker's algorithm, safety algorithm, what do we name by safety algorithm is? So banker algorithm is used to detect whether if I give these process to the operating system, whether deadlock is occurring or not occurring. That's what I am checking out using a banker's algorithm. That's what is called as a safety algorithm. It is for finding out whether a system is in a safe state or not. When do we say safe state? Safe means deadlock is not occurring. Unsafe state means what? Deadlock is occurring. I have to check whether it is safe or unsafe. And how I will do it? That's what here the explanation. Let the steps are given below. Let work and finish be two vectors of length m and n. So to do this process, we are using two arrays. One we are calling or naming it as a work. Another array we are calling it as a finish. And what is the length? What is the size of these arrays? Work size is m. Finish size is n. That's what here we mean. So work is available. So starting how much I have available. Now let us start. I'll say that Chaitra asked me one CPU, one printer, one book. That's what Chaitra requires. I'll check. I'm the operating system. I'll check whether all these three resources what Chaitra asked, whether it is available. Yes, it is available. Then what I'll do? I'll take one each. I'll give to Chaitra because Chaitra will complete her work. That's what available equal to work. I'm checking whether these are available. finish initially before starting, initially we are making finish equal to false because we have not started. So that's what finish array is false initially. For an I such that both finish and need equal, finish is equal initially false, or need equal to work, means what, whatever Chaitra need, whether it is available, whether it is given to Chaitra all three, yes I have given, because it is available with me. One CPU, one printer, one book was available, it was there, then I have given all these three to Chaitra. That's what here need of Chaitra was 3, so I have given. Work is what having available, how much is available, so that I have assigned to the Chaitra now. If no such I exist, now Bhavisha asked me how many she asked more, it is not available for me, then I have to wait. Then what it says, go to step 4. What is there in step 4? Finish, means I have to wait, or else what we do, work equals to work plus allocation, then finish equal to true, then we say okay, make the finish equal to true, go to step 2. If finish of I is equal to true for all I, then the system is in a safe state. So what it says, now Chaitra asked me, I gave 3 system. Now Bhavisha will ask me some, but because I have already given to Chaitra 1 1 1, and Bhavisha is asking me more, then I have to wait till Chaitra completes. I have to wait till Mithili gives me back her resources what I have given to her. Then only I can give to a Bhavisha. That's what here, this is what the steps till all process. Now I have 3 process, I have to complete all these 3 process. Okay, that's what about this, and we'll move on. It will be clear once we take a problem. Resource request algorithm. Now we see how to allocate the resources. Let request I be the request vector for resource Pi. If request j equal to k, then the process Pi wants k instance of resource type Rj. If request is less than equal to need, go to step 2. Otherwise, raise error condition since process has executed its maximum claim. So that's what I told. Chaitra asked me how many? 1 1 1. Check with the need, what she needed, and available in the available, then give for the Chaitra. That's what here it says. If request less than or equal to available, go to step 3. Otherwise, PI must wait. That's what I have to make Bhavisha to wait, because what she asked me 5 CPUs. Right now, it is not available with me. I have to wait till I get back the all 5, so that I can give 5 CPUs to Bhavisha. That's what here available is not, must wait since resources are not available. Pretend to allocate request resource to PI by modifying the state as follows. Available equals to available minus request. Allocation is equal to allocation plus request. Need equals to need minus request. So that's what this will be clear for you once we go for the algorithm problem. So if the result resource allocation is safe, key transaction is complete. The process PA is allocated its resource. If the new state is unsafe, then we say it is in a deadlock state. Okay. So now let us take one problem, then it will be clear for you. So take an example, the same algorithm will implement, we use here for our this one. What is Banker's algorithm? We have just seen the algorithm. Now we take a problem and we will solve. So consider 5 process. How many process I have? 5. So what are they? P1, P2, P3, P4, P5. Like Chaitra is one process. Bhavisha is one process. Mithili is one process. Who are the others? Other people who are there in the group? Sunil is one process. And one more. That's all. So like this, we may have a processors. Then uh, 5 different people. Along with this, how many resources I have? I have 3 resources. 3 resources means I may say CPU, uh, printer, books. What are those resources? What are the resources? CPU, printer, books. These are three resources. Clear about this? Consider five process. Five process means each one of you. Sunil is one process, Mithili is one process, Chaitra is one process, Bhavisha is one process. One more person is one more process. That is what is called as a five process. Along with this, three resources means what are the resources available with me? CPU, printer, book. How many CPUs I have? 10 CPUs. If I consider A, B, C as their names, what is A stands for CPU. How many CPUs I have? 10 CPUs. B is what? Printer. How many printers I have? 5 printers. How many books I have? 7 books. That's what you can see here. A, B, and C. Okay. So snapshot at a time T0. The snapshot what it gives us in the table is, that's what you can see, P0, P1, P2, P3, P4. Yes. So allocation, how many we have allocated for P0, how many we have allocated for P1, how many we have allocated for P3, P2, P3, P4. That's what allocation says to us. What is this maximum? Sunil wants how many printers, how many CPUs, how many printers, how many books. That's what here. This A, B, C is what? A is a number of CPUs. B is what? Number of printers. C is what? Number of books. That is what the allocation here. In the same way, maximum. Maximum means what? Before I start, how many I want to complete my job, how many printers I want, how many CPUs I want, how many books I want. Like that, before I start, I should give a maximum. That's what P0, how many it wants? 7, 5, 3. How many P0 wants to complete its work? It wants 7, 5, 3. In the same way, how much P1 requires? 3, 2, 2. How many P2 requires? 902. How many P3 requires? 222. Maximum to complete P3's job. The same way P4, how many it requires? 433. Yes, clear? Okay. Now come back. So now doing this total, allocate it. So before we start, what is this P1 is doing? P1 is allocated how many, this if I say CPU, this is printer, this is books. So P1, what it is allocated? First 0, 1, 0. What do it mean? What does it mean? What does it mean? P0, how much allocation is already done? Already done. How many? Printer. One printer is allocated. B stands for printer. A is what? A is what? For us, do you know anybody that in this how to use this drawing? In Zoom, I was doing no writing. I just want to add all this. How to do here? Any idea in Google Meet? What options we have to select? Don't know. Got it. I want a pen to draw here. How to do that? Anybody? Sunil? Sunil, you know how to use a pen? In Zoom, I was using, right? If I want a pen here. Okay. So what we have to do here is, so P0 is 0, 1, 0. P2, add all these. So how many? 3, uh, uh, how many printers are already allocated for 5 processors? 2, 3, 2 is how much? 5, 6, 7. So here you can add 0, 2, 3, 2, 0. If you add all A's, what is the total here? What's the total here if you add? If you add, what's the total? Total is 7. In the same way, how if you add all B's, that's what B's here in the allocation. In the first table, you add all B's. How much is a B's required? One is used by P0. P3 is using 1. So add 2. Then come back P3. How much? 0, 0, 2. P2 wants how much books? 2 books. P3 wants 1 book. P4 wants how many books? 2 books. Add all this. How many? 2, 1, 2 is what? 5. So how many we require? 5. So now add all this. How much is required? This first A, add all first column of A. 0, 2, 3, 2, 0. What is the total now? 7. 7. So in the same way, add all B's. 1, 0, 0, 1, 0 is 2. Yes or no? All B's if you add 2. And here C's also you come 0, 0, 2, 1, 2. What is that? 5. Now what is our total here? 7, 2. What is the last one? 5. Got it? This first one, allocation. Add all the allocations. How much I have allocated? For P0, how much already allocated? For P1, how many allocated? For P3, how many allocated? For P4, how many allocated? Add all this. We will come to know that first all A's means 7. All B's what? 2. All C's is what? 5. 7, 2, 5 is already allocated for 5 processors. That is P1, P2, P0, 1, 2, 3, 4. For all this, we have already allocated what? 7. 7. A7s we have allocated. B is 2. C is 5. Okay. How much total we were having? Total they have given 10 A's, 5 B's, C 7. Now subtract. How much was there here? How much was total for A? 7, right? First column. 2, 3, 2 is what? 7. 10. How much total we were having? 10. 10 minus 7 is what?
3.
So that's what here, the last column you can see, first A is 3. Yes, getting? How this 3 is got it. Okay, next. How much B's already we have allocated? 2 we have allocated, right? 1 for P0, 1 for P3 we have given. They have asked, we have given 1, 1. So 2, B2, 2. How much total it was having? 5. 5 minus 2 is what?
3.
3. So you can see here B in the last column you can see 3 is there. 3, 3. In the same way, here C, we have added C. How much was the total of C? 0, 0, 2, 1, 2. What was total? 5. Yes. So 7 minus 5 is how much?
2.
2. That's what you can see here. 2. 3, 3, 2. Last column clear about that? Available. Current available resources. How many currently we have available? 3, 3, 2 is available with me now. Right now, how many is available resources? How many CPUs? How many printers? How many books? How many is right now is available? Out of 10, already 7 I have allocated. Out of 5, already 2 have allocated. Out of 7, the remaining what I have right now is only 2. Clear about this? 3, 3, 2 are my resources currently available. Out of 10, we have already allocated some. Out of 5, we have already given. Out of 7 C's, we have already given to them. Remaining how much I have right now? I have 3, 3, 2. Clear about this much? Clear? Okay. Okay, now come back to calculate a need. So to calculate a need, so we know that what was the need for Chaitra, what was the need for Bhavisha, what was the need for Mithili, what was the need for Sunil, we have here. So how much Sunil wants? Sunil wants, let us assume P0 is Sunil. Sunil wants to complete its job. How many A's? 7 A's he wants. How many B's he wants? 4. How many this one he wants? C. So let us calculate this need matrix. How do we calculate this? So P0, so how much is this one? In this calculate, first one, how many is there? Allocation, the top table. Allocation of A maximum. So maximum 7. Now come back. You just have 3.1 is a table where I am trying to write 3.2. So how I am writing 3.2? Now maximum in P 3.1 is what? 7, 5, 3. 7 minus 0 is how much? 7 minus 0 is how much? 7. 7. So that's what here in the need table you can see 7. 5, come to the first table, 5 minus 1. 5 minus 1 is how much?
4.
That's what you can see in the down table. P04 is available. And come back, 3 minus 0 is how much?
3.
3 minus 0 is how much?
3.
3. That's what here, 3. That's what clear. 743. In a need table, we have come to 743. Clear about this? How much Chaitra is required? Sunil require. Complete his work. He has told me initially he wants 753. Yes. How much he requires? 753 he requires to complete its job. Out of 753, initially already B1 was allocated for Sunil, where B1 was allocated. So remaining was 743. Clear about this? Okay. Now come back, P1. What is P1? Chaitra wants how many? She told me initially only she wants 3, 2, 2. How many she wanted? Maybe 3 CPU she wants, no, 2 printers she wants, 2 books she wants. Out of this, initially which one I have given to her? Out of A you can see 2 was allocated to her. That's what here. 3 minus 2 is how much left over? 1. That's what for Chaitra right now I have to still give. How much still I have to give? I have to give 1 ace. In the same way, 2 minus 0 is what? 2. 2 minus 0 is what? 2. So 1, 2, 2 resources still I have to give for Chaitra. Yes, I have given 2 A's to her before only, but still how much she need? Still she need 1 A's, 2 B's, 2 C's to complete Chaitra's work. That's what here P1 still required 1, 2, 2. In the same way, P2. P2 is what? P2 is Bhavishya. How much she told initially only, how much she asked me, she want how many A's? 9. How many B's? She don't want B0. And how many C's she want? 2. Out of this, how much was allocated already to her? 3 A's was allocated, 2 A's was allocated, 2 C's was allocated. Now, 9 minus 3 is how much? 9 minus 3 is how much? 6. That's what you can see here in need matrix, we have 6. Yes. So in the same way, 0 minus 0, 0. Then 2 minus 2, already I have given 2. Now 2 minus 2 is 0. That's what Bhavishya still require. Already I have given her 3 and 2. But still how much I have to give? Remaining how much I have to give? I have to give 600 for her to complete her job. Yes, clear about this need matrix, need table? How did we get this 7, 4, 3, 1, 2, 2, 6, 0, 0? Clear? The first table max minus allocation. Yes, the same way. Now Mithili wants 2, initially she told me she want 2 A's, 2 B's, 2 C's. Yes, first I have what I have already given to Mithili. I have given 2 A's, 1 B, 1 C's. And now still how much pending is there to give to Mithili? Calculate this. 2 minus 2 is 0. 2 minus 1 is 1. 2 minus 1 is 1. Means what? I have already 2 A's I have given. So I'll not give anything because she asked me only 2. So I have given 2. And how many B she asked me? She asked me, starting she asked me 2. But already 1 I have given. Still how many I have to give? I have to give her 1. That's what 1 here. 1 B's I have to still give. And what is C? Initially she asked me, C also she want 2. And I have given 1. Still left over how much I have to give to her? I have to give 1. That's what here 0, 1, 1. Is that clear? Is that clear for you people? Okay. The last one, P4. What is this? P4 is also same way. 4, 4, 4, 3, 3 was asked me beginning. But how much we have given? We have given 0, 0, 2. Only 2 C's we have given. Now still how much I have to give for P4? I have to give 4 minus 0 is 4. 3 minus 0 is 3. 3 minus 2 is what? 1. Clear about this? This is a need matrix. Table 2. How did we reach for table 2? Clear? Clear or you want me to explain again?
Yes, ma'am.
clear for you? How
Clear,
did we
ma'am.
get the need table? So need is clear. Need is what? You asked me P0, P1, P2, P3, P4 are the processor. How many processors we have? 5 processors. How many resources are there? There are 3 resources. That is A, B, C. Initially, starting only, all the processor have to say me maximum how much they require. This is 3 resources to complete their job. That's what here max column you are saying me. That is P01753 to complete its job. That's what maximum. And before some resources were available, I have given. That's what here A initially was given with only B. P0 allocation was 0, 1, 0. That I have already given. But still remaining, how much I have to give for P0? I have to give 743 to complete P0's work. Clear now? Now need matrix, I think it should be clear. Need, how to calculate need? Maximum minus allocation. In the table 1, in 3.1 table, we have max. Take max minus allocation. That will give you a need matrix. Okay, now coming back to 3.3. So what is this 3.3 says to us is, so here in this we have just written how much this allocation is, how much it was a need, how much it was needed, and how much is available for me right now. So right now, what is available for me? How many A's is available? How many B's is available? How many C's is available right now? You can see with respect to your table. In our first table, we have 3, 3, 2. How many CPUs right now I have with me? How many printers I have with me? How many books I have with me? That's what here available, current available. How much is available with me? 3, 3, 2 is available. Resources right now with me. Okay, come back to process P0. P0 is required. How much P0 is requiring? 743. Can I give for right now? Is it available with me? 743 processors. Is it with me? 7 A's, 4 B's and 3 C's is available for me with me right now?
No, ma'am.
How much is available with me right now?
332.
Yes, correct. 330 is only available. Can I satisfy P0 to complete its job? No, I cannot complete. Okay, now leave P0. Come to P1. P1, how much request it is asking? 022. Is it available with me?
Yes, ma'am.
It wants 0, 0 A's, 2 B's, 3 C, 0. Is it available with me?
Yes, ma'am.
Yes, it is available. Then I can give how many B's I can give? I have 3, but they are asking 2. Yes, available with me. Then I can give 0, 2, 0. And when I give 0, 2, 0, then P1 will get completed its work. Yes or no? Available with me is 3 A's, 3 B's, C2s. Now P1 is asking me only B's. How many B's it is asking? 2. Yes, it is available with me. I can give for P1. It will complete its work. That's what here 0, 2, 0 is the one. Okay. If I give, P1 will complete. So after it completes, it will give back me all whatever resources it was having. Now let us assume Chaitra wants 2 printers. She asked me 2 printers right now. You can see here. Once she completes its job, whatever was there with her, she'll give me back all because she has completed her work. That's what it means here. So how many she'll be, I have to add because P1 is completing. If I give 2, 0, 2, 0, clear? Then add whatever is there. Allocation, how much we have allocated to them? 3 A's, 0 B's, 2 zeros. Then add to 3, 3, 2. How much will be now available for me? Because P1 completed its job. Chaitra will give me back whatever I have given to her. What I have given? I have given 3, 0, 2. Add this 3 A's to already available for me. How much was available? 3 plus 3 is what? 6. 3 and 0 is what? 3. 2 and 2 is what? 4. Now what is available for me? 6 A's. 6 A's is available. 3 B's is available. 4 C's are available. Why this is increased? Why this is increased? Why this is increased? Why my available is increased? Because Chaitra has completed her work. Whatever I have given the resources, she has given me back. Yes, clear? Okay. Now come back. Now let me see. Can I give my resources to P2? P2 is requesting how much? P2 is requesting how much? 600. Is my 6 available for me with me right now? 6 A's is available with me? 6 A's are available with me? Yes, available with me. 6, 3, 4 are available with me right now. Then I can accommodate for P2? Yes, I can accommodate for P2. If I give 6 A's, yes, 6 A's is available with me right now. How many 6 A's is available? 3 B's is available. 4 C's is available. So if I give, P2 will complete its work. Okay. Now when P2 completes its work, now let us assume Bhavishya want 6 A's. B's she don't want. C also she don't want. If I give to her, she will complete her work. As soon as she completes her work, she'll give me back all whatever resources I have given. Yes, that's what here. P1 we have already completed. Now P2, yes, I can give. P2 will also be complete. When P2 is completed, what resources she will give me back? She will give me back here whatever I have. 302 I have allocated to her before. Before I have allocated 302. That she will give me back. So add that 2 already existing. What was there? 634 was there. Now add to her. Now 302. Now how much will be there? 4. Add all of them. 4, 5, 6, 3, 6, 6, 9. 9, 3, 6 is available for me. I'll stop here. Again, we'll continue in the next class. Can anyone just do small thing? I want a pencil here. Pencil in this meet. How to get a pencil? So that I can write here, it will be clear for you. Yes? Can you people please check out how to get a pencil to write on the PPTs in the Google Meet? That I was doing in Zoom, but here in Google Meet, it is not available for me. Okay, I'll stop now and we'll continue in the next class.